A solid copper cylinder of length L is placed on a horizontal surface and subject to a vertical compressive force F directed downwards and distributed uniformly over the end face. What will be the resulting change in the volume of the cylinder? Okay, so this is the situation. So force is applied on the upper face of a cylinder which is acting downwards and it is uniformly distributed all over its surface. And suppose the cylinder is placed on a horizontal surface, then the surface will exert a normal reaction to balance this force, and that force will be in upward direction. So this cylinder is compressed from both sides, so its length L will decrease, but it will increase the radius of the cylinder, and let's see how. And we have to find the volume, change in volume of the cylinder. So normal stress, the stress on a section where force acting is normally on it. So normal stress here is F over A, and with a minus sign because this force is compressive in nature. And this normal stress will produce a longitudinal strain, which is defined by this formula, normal stress over Young's modulus. What is longitudinal strain? Strain means change in length over length. Longitudinal means that side which is longitudinal. And what is longitudinal? If we have two sections on which pure normal stress acts, then the distance between those two sections is called longitudinal side. So longitudinal strain is change in length upon length. L is longitudinal side, while R is perpendicular to this L, so it is called lateral side. So how we define longitudinal? First we see the two sections on which the force is normal. So here we have the upper face and the lower face on which normal stress is being acted, and the sections on which normal stress act uh, are separated by some distance, and that distance is called longitudinal side. So here it is L. So longitudinal strain. So this longitudinal strain will give change in this length upon original length. And while lateral strain is defined by this formula, minus times Poisson's ratio into longitudinal strain. So this is the formula for finding lateral strain. Strain in lateral side. Lateral side here is capital R, because it is perpendicular to this L. Longitudinal strain is dl over L, or you can write delta L over L, and this is equal to normal stress over Young's modulus. And now you can kind of verify why this minus sign is being put here, because we know that longitudinal strain, this L will decrease due to this compressive forces, so dl has to be negative. So to get that negative, we put a negative sign in the stress itself, and we can say that minus sign is associated whenever we have a compressive force acting on a section. Lateral strain is dr over r in here, and which is using this formula, minus mu times longitudinal strain, and longitudinal strain is this much, so just put the value. The volume of this cylinder is pi r square L. Just take log on both sides, just use the property of log here, and then differentiate this. You can verify. Log pi is a constant, its differentiation is 0. Put the value of dr over r from here, put the value of dl over L from here. Okay, so dA over V, we have got this expression, and V, original volume, can be written as cross-section area into length, and this is expression whole is copied here, multiplied by A into L. A will get cancelled throughout, and this L will come upstairs, so dV will be of this value. Okay, thank you.